ste se udeležili našega predavanja, in sicer danes nam bo Katja Džepina predstavila predavanje z naslovom Majhni delci so vsepovsod okoli nas. Katja Džepina je naša sodelavka iz Centra za raziskave atmosfere in vam bo tudi to predavanje bo potekalo v angleščini. Tako da jaz bi kar prosila Katjo, da začne z njenim predavanjem. Hvala.
Hvala tebi puno, Petra. Thank you very much, Petra. So I don't feel safe with my Slovenian yet. And thank you very much for the ability to do this presentation in English. So this presentation is aimed at high school students. So I will talk about the basics or the general properties of the atmospheric aerosol or particles or particulate matter, how we call it. Petra already introduced me, so I'm Katja Džepina from Center for Atmospheric Research. And to start here, I'm showing you the eruption of a volcano, which is spitting out numerous gas and particle phase species. And particles are what we can see because we cannot see gases with our own eyes. I hope to prove it to you by the end of this talk that particles are indeed all around us. So here's the overview of my talk. If we usually say if I'm too boring and you fall asleep, so you can catch where I am. So first I'm going to say something about the properties of atmospheric aerosol. Then I'm going to talk about their influence, how they influence human health. Then I'm going to say a bit on air pollution, climate change, and then I'm going to conclude. And here in the outline, you can see the terminology which I'm going to be using interchangeably. So we talk about atmospheric particles or aerosols or particulate matter or PM. So let's go into the main properties of aerosol then. So very rigorously defined, aerosol is suspension of solid or liquid particles in the air. Colloquially, when we atmospheric scientists speak about aerosol, we mean the little particles only. We don't refer to the gas phase usually. And as I said, our atmosphere of the planet Earth is loaded with them. One of the main aerosol properties is their different size. The smallest of them are, I believe, the smallest detected are about 1.7 nanometers. And we all know nanometer is million times smaller than millimeter. So they're really, really small. So they're in the nanometers range. And the largest ones are visible. It's, for example, dust, and we know it from cleaning weekly our places. I think here in Aidovčina it's very clean because the atmosphere is very non-polluted. I come from Zagreb, Croatia, and we live downtown Zagreb. So because of the traffic and so much man-made commotion in the big city, I could be cleaning daily dust there. How does that look like if we compare? So some things that we know very well is human hair and also the sand on the beach. So when we go to the beach, that sand grain is about 100 micrometers, 90 micrometers big. And that's very, very large. So it's not aerosol by strict definition. It cannot float in the air. Human hair is about half that size in diameter. And then when we talk about particles which are larger, we call them PM10, particulate matter with aerodynamic diameter smaller than 10 micrometers. And that would be dust, that could be some biological particles like pollen, and they're a little bit larger. The finer particles, the small ones, are smaller than 2.5 micrometers in their aerodynamic diameter. And this is what my research is mainly about. They can be composed of many, many species, organics, inorganics, metals, etc. The other very important property is their number. And very clean air will have very few particles per volume, whether very polluted air will have a lot of them per volume. The photo I'm showing you here is from the Azores when we ran a research station at the top of the volcano at the Pica Mountain in Azorean archipelago. And here is my friend and colleague Kendra, and she's chugging down from the top of the volcano at 2,200 meters above the sea level. And we measured the number of particles there. And there we had about 20 particles per centimeter cubed. The photos I'm showing you now are in Mexico City, where we had more polluted air. It's an urban environment. And you can see two photos. The top one is taken on the clean day. And on the left side of this photo, you can see the mountains surrounding Mexico City, and the hill on the right side, there is a hill, is quite nicely visible. On a hazy, more polluted day, when we had 20,000 particles per centimeter cubed, so that's the number from the instrument in Mexico City. On the left side of this photo, you cannot see the hills, the mountains around Mexico City, and the hill on the right side is very hazy. So that's a polluted day. We can have particle numbers that are even higher than that. So tens or hundreds of thousands per centimeter cubed. So another property of particles is their origin. And very broadly, we can define them as biogenic or natural, or anthropogenic or man-made. They are made by human activities. And here, some of the biogenic examples are shown at the bottom left pictures. Now you see the sea. Sea emits particles by breaking of the little waves. And there is some formations too. Then you can see volcano, which can explode. And you can also see the forest fires. With respect to the forest fires these days, being a natural source, we should be careful because it's doing its own thing. So forest fires are normally, without the climate change, they are indeed natural processes emitting particles. Nevertheless, because the atmosphere is warmer and our environment is drier, there is less rain, we need to really think about the influence of humans on the forest fires too. I'm really sorry for this, folks. It's automatically going. I'm sorry for this. So the other type of. I'm sorry for this, guys.
Yeah, I will ask you maybe manually to move it that we see it. Yeah.
Okay, I didn't realize it started moving by itself. I'm sorry, Saim. I always turn it off.
No, it's okay.
Yeah. Okay. So as I said, another type of particle sources is, of course, human activity, and this is the little on the bottom right. You can see it's emitted from the heating industry, different types of vehicles, etc. So with this, we separated particles types by natural or man-made. We also can separate them by their let's say, emissions or how they are formed. So primary aerosol are the particles that are emitted directly. So the truck goes and it emits some soot, or the fire burns and it emits particles in the atmosphere. With those particles, some other species like gases are also emitted, and those gases can get oxidized in the atmosphere. And with this, we get secondary formed aerosol. So primary aerosol is directly emitted, and secondary aerosol is the one that is being made through physiochemical processes within the atmosphere. All of them are filling the aerosol load in the atmosphere, and importantly, they are connected to to the climate change, and they can influence the climate in two major ways: directly through the interaction with incoming solar radiation, or indirectly through changing of the cloud cover in the atmosphere. And I will say a little bit more about that later. So from the aerosol, we can have different phenomena for which you may have heard, like acid rain, deposition. Acid rain and deposition, many years ago, we were hearing how in Greece, the ancient monuments and artifacts were being, under brackets, eaten by acid rain and that deposition. So in Western society, we resolved the acid rain problem. Then they can reduce visibility. I'll show some examples of that. And they can also have health effects. Okay, composition is another very important characteristic of atmospheric aerosol, and very broadly, they can be composed of organic and inorganic species. The figure I'm showing here is from a paper from about 15 years ago, where we covered all the world with measurements of aerodyne, aerosol mass spectrometer, and some of those locations where we measured are remote, like Okinawa Island in Japan, or Okinawa, they are non-urban. And then we had places like Houston and Mexico City. So the colors with which the places are written are for urban or remote places. And at the top left, you can see the bulk composition of this aerosol that we measured. So the green is organic, and the others are nitrate, sulfate, and ammonium, or inorganic parts of the aerosol. And in principle, the further you go, the further from from urban environments you go, you could have more and more organic part, because not only they're directly emitted organic species in urban areas, but they are also photochemically formed in the atmosphere, secondary form. So this figure shows you, again, depending on their composition, the aerosol will have different influence on interaction with incoming solar radiation or radiative forcing. They will have influence on visibility and human health. And this is all bulk composition. Now, additional thing with composition of the aerosol is they are composed organic species, particularly, of thousands and thousands of compounds. We still do not know complete molecular composition of organic aerosol, and I will now illustrate you through a modeling exercise of our French collaborator, Bernard Demont. Why is it so demanding to determine the exact molecular composition of aerosol? So let's take one simple.
Katya, I'm sorry, the slide is not moving. Where it's in the page where it's written, where do particles in atmosphere come from? Are you in the same page?
Yeah, no, I'm not. I don't know why.
It will be nice if moving is done manually.
I'm really apologizing. Can you see now? I can leave it.
Now
like
it's page 11, yeah.
I'm really apologizing. It's something with my laptop. I didn't realize it. So let's not project it. Let's just leave it like this. It happened before.
Yeah.
Same, I'm really apologizing.
It's fine.
So here is the slide where I was talking about primary and secondary aerosol and their direct and indirect effect on climate. And here is the slide where I showed the different composition of the particles. And here is the slide where I'm showing why is it so complicated to have to determine the molecular composition of organic aerosol. So if you take one simple pentane, so it's 5 carbons alkane, right? And this one is the very top molecule on the left-hand side. And if you oxidize that species, you will get all the species, all the molecules. These are all the possible products of this one first generation oxidation. And then if you take one organonitrate, 3-pentyl nitrate, and you oxidize that species, you will get the other bunch, all of those species that are on the right-hand side now. So to determine the exact molecular composition of all organics in the aerosol is really complex, because then you would need to determine all of these species. And there are hundreds and thousands of primary emitted organics in the atmosphere. So folks, I'm really not sure how to project. Let's continue like this, if this is okay with you. Okay, so now let's say something about the aerosol influence on the human health. So the World Health Organization, about 5 years ago, has estimated that air pollution causes about 8 million deaths a year, and it called it the world's largest single environmental health risk. There's a very strong link between polluted air and cardiovascular disease and cancer, and the burden of that is mainly on the small particles. And particular burden is on the underrepresented communities around the world, such as those in Southeast Asia and Western Pacific. And out of those, low-income women, children, and elderly are particularly vulnerable. Just a few days ago, World Health Organization has put out the new guidelines for the air quality, literally 2 days ago. And the values for PM2.5, the small particles in the air, have decreased for about half now, new recommendation. And they say if those values were applied already maybe 15 years ago, 80% of, we could have reduced 80% of pollution related deaths. So that's really huge number of human lives we are talking about. So how do they interfere with human organism, the aerosol? So depending on their sizes, aerosol will or will not be entering human organism. So the large particles, the largest ones will never enter our organism, those above PM10, what we call PM10, or those with diameters above 10 micrometers. So they will be blocked by our nose, where they will get stuck on the little hair, and also they cannot follow the streamlines of the air, and they cannot make a bend through the nose into our organism. The coarse particles, up to 10 micrometers, they will stay somewhere in our upper respiratory tract, so they will not get deep into our organism. The fine particles, those smaller than 2.5 micrometers, they will enter our lungs. Those smaller than 1 micrometer will enter deeper into the lungs in the alveoles, and so-called ultrafine particles smaller than 100 nanometers can enter our bloodstream. In other words, depending what those particles carry on them, what composition they have, they're like a little very potent vehicles to put into our organism very toxic substances. And because, again, I made this talk for high school students, as Sain kindly suggested me, and I wanted to point out one more time something about COVID-19 pandemics. So we know that airborne viruses are transmitted by aerosol. They cannot be transmitted by large, very large droplets, which are formed with, for example, sneezing. Why not? Because they will fall on the ground. So if we are about 2 meters away, they cannot reach us, and B, they cannot enter deep into human organism. Aerosols, so here you have illustrated somebody who is infected and somebody who is a potential host. The infected person is always breathing. Hopefully with the masks, we prevent the larger droplets coming out. But the infected person is breathing, and all of us, when we are breathing, we are forming tiny little particles that go into the air. Once they are in the air, they can stay there for hours. The person who is breathing in can inhale those particles because they're staying for hours in the room, for example. So my main message here is for all of us and the students, if they're listening, we need to wear masks. I guess there are two very, very easy and absolutely non-expensive ways we protect ourselves and others, and that's to wear masks and to make sure that we ventilate closed areas we are in, if we can, by opening windows and doors. Okay, now let's say a few things about the air pollution. Okay, so here, can you see this? No, okay. So in this photo, I showed you, this was animated. I'm sorry for that, guys. So in this photo, I showed the this photo has shown the greater Beijing area before and after a pollution episode. And because I cannot project it now, I'm afraid you will not see it. So this is the satellite picture from the air, where you can see a highly polluted day. And here you can see in the day in Beijing, when we had the concentration of the particles about 300 micrograms per cubic meter. And this is above the hazardous level according to the guidelines by the World Health Organization. So there is a drastic difference in the days which are clean, where you can see crispy clean atmosphere, and this building is very nicely visible. And now when you have a very, very polluted day. One thing that we have been working on together with Grisha, two of us from UNG, is the pollution in the Western Balkans. Actually, we have some of the worst global air pollution in the Western Balkans, and there is no state-of-the-art research trying to understand the sources, transformations of that pollution, and to give the recommendations so that it can be, so that we can clean the air. This photo here shows Skopje, Northern Macedonia, in January 2017. And these, all you can see here are aerosol, or this is the pollution. On that day, the PM10 concentration was above 1,200 micrograms per cubic meter, and the World Health Organization daily recommendation for those particles is 50 micrograms per cubic meter, and 300, above 300 is the hazardous level. So it's dangerous for all humans. So this is manifold times higher than that. One thing that I'm always wondering is if people will take the message that we can make a lot, because when you are showing that the extent of a problem, it's easy to take home the idea that there is only doom and gloom, which is not true. So here I'm showing the capability of the humans to do research, to understand, and to resolve the problem. Los Angeles used to be the, let's say, symbol of summer air pollution, and that's why we have a type of air pollution which we call LA smog. And this is the air pollution being formed during hot days, so-called photochemical air pollution. The photo here is showing you Los Angeles on October 5th, 1980, and there are no clouds on this photo. This is a black and white photo, granted. However, this haze that you see is the cover of photochemical smog in Los Angeles in the 80s. So the air quality was really, really bad. There was a ton of research being done by scientists from America and the world. And then now the photo I'm showing you in August 1998, you can see that there is still this milky look to the clouds, to the sky, I'm sorry. However, there is a tremendous difference from about 20 years before in 1980. So already there was a significant improvement in the air quality. And now if we keep on moving about 10 years afterwards or 15, you can see that in this photo, the skyscrapers are really nicely visible, and this milky look of the sky is not there anymore. So I would say this is one of the potential success stories, how some problem that was really large, influencing human health and environment, was resolved within decades through the science. Okay, now let's mention climate change again. So we have significant influence of aerosol on climate change. And actually aerosols are the largest unknown in the estimation of radiative forcing or the changes in energy budget of the planet Earth due to the human activity. So they may be small, but they are very mighty. How do they influence climate change? If you may remember that I said there are two main mechanisms, direct and indirect effect. So direct effect is by changing the radiation balance of the incoming solar radiation. So we know from when we were kids, when it's hot, we wear white, right? It's reflecting. So white particles, they will reflect the incoming solar radiation. And that's, for example, sea salt or sulfate and droplets of clouds are also white. Whether the black particles, darker particles, they will absorb the incoming radiation. And that's, for example, black carbon or soot. And our Gorica is the world leader in black carbon research. The indirect effect of aerosol is through changing the cloud cover. So aerosols are a necessary part of cloud formation, and if we have more aerosol in the atmosphere, the cloud formation will be changed too. I'll say a little bit more in the next slide. So again, this is the slide I showed before, where we have the direct and indirect effect on climate. So let's talk about indirect effect on climate of aerosol through so-called cloud condensation nuclei, which are necessary for formation of clouds. So clouds are tiny droplets of ice or liquid or ice. And the photo I'm showing you here is from the top of the Pico volcano at the Azores, where we were above the planetary boundary layer, where the clouds are being, and you're above the cloud cover. So it's really beautiful, and you can really see them being formed. There is a saying around meteorology community that the weather is formed in the Azores, and you can really see it beautifully there at the top of this volcano in the middle of the Atlantic Ocean. So formation of clouds all of them include the same steps. You have to have a warm, moist air, which is filled with water vapor. Let's say at the coast, above the sea. This hot, moist air full of water vapor or water in the gas phase wants to go up. So it goes up in the altitude where it gets cooled. It's cooler up there. It's very hard and not thermodynamically favorable for this water vapor or the gas phase water to just pop and become liquid. So it can happen, but it's not very likely. What is happening is that this hot air full of moisture, full of water vapor, is looking for little particles to condense upon. And once those particles are then called cloud condensation nuclei. And once we see the cover of some particles, that water vapor goes from the gas phase to the liquid phase, it condenses onto those little particles, and that's how the clouds are formed. Now, you can imagine the scenario that maybe some hundreds of years ago, we had a certain concentration of particles in the atmosphere, which was mainly from biogenic or natural processes. What is happening nowadays, we have much more aerosol in the atmosphere. And what happens then is you can imagine that now that you have the same volume of moist air, which now has available much more particles to condense upon. What will happen then is that those clouds that are formed, they have much tinier little droplets because there is more aerosol to condense upon. The direct consequence of that is that those clouds will be lasting longer. The cloud droplet needs to grow to the certain size to rain, for it to be capable of raining, very simply said, all of it. So if the cloud droplets, when they are formed, if they are smaller, they will last longer, the clouds will be brighter, we say, and in that way, in indirect way, we will be influencing, human activity can influence the formation and the cloud cycle, and has the indirect influence on climate. So now let's conclude. I hope by now I convinced you that there is a lot of particles in the air. They have different sizes. They have different loadings or concentrations in the atmosphere, and they can have very diverse composition. That all depends on their, let's say, on their sources or their origin, and very broadly speaking, they can be emitted directly into the atmosphere, and we call those primary aerosol, or they can be made in the atmosphere, and we call them secondary produced or secondary formed. And they can be from human activities or natural processes. I hope I convinced you that they can influence human health, because very small particles enter, they follow the streamlines of the air, and they can enter very efficiently human organism, and the smaller they are, the deeper they will enter. If they have some toxic compounds on them, then they will directly cause inflammation and so on, introduce sickness in humans. One point very important for today is that there is a airborne transmission of viruses. It's important for the COVID-19 pandemics, and I really urge everybody to do two very simple and cheap, free almost things. Wear masks and ventilate the area where they're being, if they have a capability for that, ventilating, of course. I hope I convinced you that particles are a really significant part of the polluted air. When we model the influence of air pollution on human health, the major component is the concentration of small, fine particles with diameter smaller than 2.5 micrometers. That is the major portion. So they have the largest influence on disease and mortality. And also they have a significant, not fully understood influence on the climate change. And with this, I want to thank you for your attention, and I really want to apologize for the PowerPoint problems. And I will stop sharing now, if this is okay.
Najlepša hvala za predstavitev. Thank you very much for your presentations.
Petra, thank you for, yeah. Petra,
If you have any questions, please go ahead.
very interesting presentation. I mean, studies, especially since it's directly related also to human health. So here, the concern is how to keep the environment clean. With this, it comes some questions into my mind. In some places, the pollution is more, in some places is less. Especially in big cities, some of the big cities, not all, some of the big cities, they have this air pollution. And you show us, like Los Angeles, what was the cause of air pollution, like in Los Angeles, and how they improved this air quality?
So in LA, we have so-called photochemical air pollution. It's the type of air pollution. So broadly, we define it in the summer and the winter. In the summer, you have to have the strong sun. You have to have photons. So this air pollution is being formed through the emissions, man-made emissions. You have to have NO and NO2, and you have to have organics, and they are forming through the cascade of processes. They are forming aerosol and ozone. They're increasing the surface ozone level. Things they did is, maybe you know that California in general has a very stringent emission laws. So the cars have to be very clean. This is one of the things they've done. They have decreased the NOx emissions from the cars. Also, in the last decades, we have developed the filters for the cars, so they are not emitting the soot from the cars. So these were one of the measures they took. And this type of pollution is different than the one I showed you for Skopje, Northern Macedonia in the winter. There we would need to really lower the types of heating, such as wood and coal, that people are using for the domestic heating and also for the industry.
And so what we can understand is even if we see the air is not clean, so that there are different kind of sources which are causing it. And so basically it's quite complex based on the origin of this pollution. So it means the pollution in LA maybe is not the same as in Beijing, isn't it?
No.
Yeah.
No.
Okay.
So these are the broadly two different types of pollution. And they are called by the cities which were the most polluted, and I would say the most researched on. So you have LA pollution and you have, or LA smog and London smog. Maybe some of you know that there was a very high pollution event in London in the 50s, when about 10,000 people died within a week of a very high winter pollution in London. And then the estimate is within the next year, as a consequence, 20,000 more people died. This type of pollution is more typical for what's happening in Beijing. Because in the winter, there is a stagnant atmosphere. And in London, they used to use a lot of coal, and the same as in China, industry and heating is very coal driven. So then you have accumulation of those species emitted from little stoves in humans' houses used for heating, but also from the industry. And now I have to say that China is taking huge steps. So 10 or 20 years ago, China was indeed the symbol of the badly polluted air. Many years ago, I gave a talk on the black carbon observations from the satellites for China and India. And there was this photo during the day in Beijing when you couldn't see the sun and there was no clouds. It was all because of the pollution. However, they are very increasingly fast cleaning the atmosphere. And the problem is now, I'm not sure if India is moving at the same pace. The problem now remains in some other environment. The closest to us is the Western Balkan, I would say, geographically, they're the closest to us. And it's again the combination of meteorology, because you have many big cities in the valleys surrounded by the mountains. And in the winter, you have a very stagnant meteorological conditions. So the air, and then you have, let's say, much more dirty ways of heating and driving. Cars are dirtier, the gas is also of the lower quality, and all of those things are accumulating day after day, sometimes for a week or so, and then you get to really extremely high levels of air pollution.
Yeah, thank you. Thank you. Very interesting. And how about how do you judge the quality, air quality in Slovenia? Which parts are more polluted and which are less?
So I would say we are very lucky in Aidovština, and then if there is anything in the atmosphere, there are always little particles. They find them even in the Arctic and Antarctic. So that's normal part of the human atmosphere. I think it's super clean here, and then when the Bura starts blowing, it's really clean after that. I came here as a researcher on the project that Grisha got with the municipality of Canal, and there we measure a bunch of species during the winter, and it's a year-long measurement. And actually, the winter pollution can get really bad, and it's a similar story like in the urban cities in Balkan. So you have those little towns in Slovenia, and I would say in Alps region, but also here in Deskle, we measure in Deskle. When in the winter there are stagnant conditions and a lot of people are using wood for heating. So then all of that gets accumulated, and we recorded some higher levels of pollution there. I'm analyzing the data, and we are waiting for a longer term results from our collaborators in France. So I will be able to tell you much more in 2 or 3 months. Some things there were days which were really polluted. I would say little towns in the valleys of the rivers, like Deskle.
Yeah, I understand. Well,
I have a question on this
please.
topic. So the pollution is mostly because of the wood fires, or
that is correct. Yes, absolutely.
So not from the industry.
Not in Deskle. Not in Deskle, but we see super strong signatures of wood burning in the winter. And this is a conundrum. So for Croatia, I don't know if you maybe read in the paper, there is a town, a city of Slavonski Brod. It's close to Bosnian border, and across the border, across the river, there is a refinery. So there is a very pretty dirty industry across the border in Bosnia and Herzegovina. So here is the story I would like to tell you, how we always need to be careful. So for some years, the people of Slavonski Brod are having a big push that they're polluting us from across the river. And then my colleagues from the Institute of Medicinal Research, maybe 5 or a bit more years ago, they did a pilot study. They were also collecting some samples there. And it turned out that 37% of particles in Slavonski Brod is from wood burning. So between, let's say, 40%, it's not half, but it's more than a third of the pollution is coming from the people themselves, because a lot of people in the towns in the region, the entire region, uses wood for heating. I was walking my dog yesterday, and I saw a guy in Aidovština preparing the wood, with the saw. That's a very convenient and traditional way of heating. So I'm not saying for Slavonski Brod that the refinery is not adding to the air pollution. However, I'm saying there are other sources which we are causing ourselves, and I think they are low-lying fruit and easy to solve. There are, even if you want to use wood for heating, they are very efficient burning stoves. They are much more expensive, but they are very efficient in burning and they don't emit. If you put the filters at the top of your chimney, then all of that junk will not be coming out. So there are ways to prevent that pollution coming out.
I have the stove on this wood pellets, and it has like a filter to introducing air inside. And I know that when it's turned on, you don't see any smoke out of the chimney.
Yeah.
So
What you see are aerosols. So if you don't see it, there shouldn't be any aerosols coming out.
good.
Yeah.
Yeah, it has filters already inside. It's a bit expensive. It's true. It's more expensive than normal wood stove, but I can see, and also you don't smell any burning in the.
Yeah.
And is it possible to put a legislation, for example, since also I remember there was one student presentation with a mentor, that kind of individual project in our faculty. I forgot the lecturer name, Astra Grigorca, right? She.
Astra Gregoric.
Yeah. Yes, sorry. She and her student, they did measurement Savinjeva's near Ljubljana village. They put sensors, a house which is close to the road, and they measured the air pollution. And what they found is during the winter season, the pollution is higher, and it's caused by houses which burn wood. And the goal was, and then also they compared the summer season. Summer was really very little, and they conclude that car pollution contributes very little. Although the house was close to the road, but cars are not contributing so much. So, and my question is it possible to put a legislation which somehow puts some kind of order that people, they don't burn randomly, like cars nowadays. There is a requirement for car filters. If it is not good during technical checkup, they say, okay, this car must pass. I cannot pass the car check. This yearly, every year, the checking meet the conditions. So, is it possible to introduce some kind of like laws and try to make it?
Absolutely. It's up to, so we do the science, we don't push, let's say, politicians or the governing bodies to do, you must do what I tell you what to do. That's the decision from some other people. It may be that, so Općina Kanal has funded Grisha to do the measurements for 1 year. And the hope is, once we show our results, if we convince them that the particles are very toxic and dangerous during the winter,